Hello everybody. Today we'll talk about SmartWeb system architecture, and the final part will be about single room control, how we do it. So here is the network architecture of SmartWeb family controllers. Uh, as you know, we are dividing the complex system into smaller parts. We call it programs, and we employ an object-oriented approach. It might sound complicated, but eventually it's not that hard to understand. Here is a relation of the objects you find in our system and their respective interfaces or classes, or how you call it. Uh, so, uh, to simplify things, we divide any system into three parts. The temperature sources, consumers or heat consumers, and room devices. So, when you talk about temperature sources, it could be any kind of sources. And for example, usually it is like boilers or chillers, any kind of boilers here. Uh, so if your system have only one boiler, it and it is the only in your system, all these consumers talk to the boiler as a temperature source. So every boiler is already a temperature generator and a temperature source. Also, when you have several boilers, you will have most probably a Cascade Manager in your system. A Cascade Manager just acts as a manager who decides which boiler needs to run first and second, and how many boilers will run, and what power every boiler needs to maintain. So if you have several boilers, you make a Cascade Manager and connects each of the boiler to the Cascade Manager. So then the Cascade Manager will talk to them as temperature generators. So it could be boiler, chiller, or any other kind of boiler if we make another one, for example. So for Cascade Manager, there's no any difference. It tells the temperature generator that you connect to it with required power and required temperature if boiler does not support power manipulation of power. Then we have a consumer part, which are essentially like circuits, hot water, pools, ventilation, or snow melting system, any system that does not produce heating but consumes it. The simplest thing is that consumer, any consumer you see here, just requests temperature from temperature source, which could be again a single boiler, or could be a Cascade Manager that operates with boilers, chillers, and so on. So they just require temperature. Also, I need to say that there is a special type of consumers named circuit, because circuits can have room device or room devices that are connected to circuits. Oh, there is a misunderstanding here. We should connect it to circuit, not to consumer. Sorry. So it could be a heating circuit or could be a ventilation for now. So room devices just tells their respective heating circuits or ventilation or any kind of circuits their heating requests, which is essentially a current temperature minus requested temperature here. Okay, so to top it all, I'll show you the picture of a typical heating system and how we could see all these structures in a typical system. So here is a heating system you could usually find in Russia without any problem. So you have like several boilers, and you have, for example, a heating system manifold here. We called it a collector. Here you can have a water storage or just a pipe. So then we have some mixing circuits here, one and the second. And I have a, for example, domestic hot water. So any heating circuit here is essentially a circuit, and together with hot water, they all are consumers. So all the consumers, they just talk to, in this case, to Cascade Manager and tell them their required temperature. So the Cascade Manager could operate with boilers to achieve the target temperature. Then talking about single room control. Here is, for example, a typical house. And you can see here some rooms. For example, this is the bathroom, or the first floor living room, second floor living room, and the third floor. And here you can see that bathroom is heated only by a warm floor, underfloor heating. In the first and second floors, you can see it. They are heated by underfloor heating and both the radiation heating. And on the top floor, you can see there are only radiators installed. So you have two heating circuits. For system, it doesn't know really what kind of heating circuit is it. Is it a circuit for underfloor heating or for radiator heating? So then the pipes lead in the radiating system, for example, to two-pipe system that connects to all of the radiators installed. And in case of underfloor heating, it leads to a manifold, and then with the star topology to each of the underfloor heating little circuits. Then, for example, here you can see these controllers for rooms, for the first, the second, the third, and the fourth room. And they are connected to the circuit that provides the heat to the room. In the first case, it is connected only to the underfloor heating circuit. In second case, it is connected both. In third case, the same, it is connected both. And in fourth case, it is connected only to radiator circuit. So these circuits receive the target temperature and current temperatures of all of these rooms and modify their requested temperature and the target temperature for the flow. So flow temperature here and here to achieve the worst case scenario here. So that is the system. Then they modify their not only target temperature here, but also requested temperature to the heating for the temperature sources for the Cascade Manager. And Cascade Manager tries to maintain the highest one from these two set points. Also, when domestic hot water start to operate, I think it would request a much higher temperature to the flow, and Cascade Manager would choose this request as the most priority one because it is highest, and then we'll start to operate boilers with higher temperature. I think it is quite understandable system. Maybe if you have any questions about single room control, how they do it, I'll tell more in the next videos. So, thank you for your attention.